Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about what is tension and compression. What is tension? Tension word becomes from a Latin word meaning to stretch. Testing part of the force, like one type of pull force. All physical objects that are in contact may exert forces on each other. This contact forces different names based on these types of objects in contact. Where one of the objects exerting the force happens to be a rope, string, chain, or cable, we call the force tensions. What is the tension force equal to? This system has a constant velocity, and there is an equilibrium because the tension in the cable, which is pulling up the object, is equal to the weight force, i.e., mg, where m is a mass, and g is the acceleration caused by gravity, which is pulling down the object. The formula of tension: T equals m times g, where m equals mass/weight in kilogram. G equals gravitational force. Example of tension force: where you pull on an object with a rope, the rope will stretch slightly. This stretch in the cable can cause the cable to be taut, which allows the cable to transfer a force from one side of the cable to the other, roughly similar to how a stretched spring will pull on objects connected to it. This stretch of the cable is usually too small to notice. Therefore we typically ignore the small stretch that occurs in cables, ropes, and wires. However, if the forces involved are also great, the large amount of stretch may cause the rope to break. So it is advisable to check the tension limit for any cable or ropes you plan on using. What is compression? The compression force is the force generated from compressing an object or substance. When shearing forces are aligned into each other, they are called compression forces. The compression force is used to power everything from compression brakes to hand tools. The compressive strength of materials and structures is an important engineering consideration. The compression force can be visualized by placing an object on a spring. When the spring is compressed and then released, the object is ejected into the air. This is the result of the compression force that is generated from compressing the spring. What is the compression force equal to? The compression force is usually captured in Newton, N, defined as a unit of force that gives to a mass of 1 kilogram an acceleration of 1 meter per second squared, ms2. Commonly represented as A. The formula of compression: N equals m times A. M equals mass/weight kg. A equals area. Note: compression force examples. Above figure shows another common visual example of compression force: the act of pressing two ends of a spring together. As compression force is applied to the spring, the spring's physical shape becomes compacted. When the compression is released, the spring immediately expands outward and back to its normal shape. Why test for compression force? From a design engineer's perspective, there is a lot to be obtained out of quantifying how a device, product, or structure responds to compressive forces. Compression force testing may yield important information in a variety of facets. Material selection. In the case of material selection for product design, a compression force test may be used to help design engineers zero in on the material optimized to withstand compressive environments. Competitive benchmarking. This compression force tests may help design engineers improve the features of their product designs by capitalizing on competitors' shortcomings. Meeting internal or third-party certification standards. Compression force tests may be integrated into certification processes like ISO, ASTM, and others. Quality testing. Compression force tests may also be a last line of defense for products, where such a test will help identify potential product defects. The test can also be used to help identify if something in the manufacturing process has to be adjusted. Difference between tension and compression. Sister no. Tension. Compression. 1A tension force is one that pulls materials apart. A compression force is one that squeezes material together. 2The force that tries to elongate a body or an object is called tension. The force that tries to shorten the body or an object is called compression. 3 effects of force. The overall forces are pulling away from the object. Effects of force. The forces acting upon it are directed toward the body. 4 related to object. Can be related to pulling on the ends of a rod. Related to object. Can be associated with pushing on the ends of a rod toward the middle. Sister no. Tension. Compression. 5 Method. A force promulgation method can be used to the transference of force. In the hydraulic system as pressure 6 applicable, only applied in solid strings. Applicable can be valid to any material. 7 Position of applied force, always outward from the object. Position of applied force, always inward to the object. 8 Considered as force. Considered as, it is a phenomenon. 9 Examples: ropes, the cable of crane, nails, threads, etc. Examples: concrete pillars. Summary: compression vs tension. A tensile force is one that pulls materials apart. A compression force is one that squeezes material together. For example, if you pull on a strong rope, it can support a large amount of tension. If you push on a rope, it cannot resist compression very well, and just bends. What is tension and compression? A tensile force is one that pulls materials apart. A compression force is one that squeezes material together. For example, if you pull on a strong rope, it can support a large amount of tension. If you push on a rope, it cannot resist compression very well, and just bends. Compressive force example. Concrete is an example of a material that is strong in compression and weak in tension. This is why it is useful in walls, such as brick walls, where all the forces from the bricks, the upper floors and the roof act as compressive forces on the concrete bricks. Tension vs compression truss. When a member force points toward the joint it is attached to, the member is in compression. If that force points away from the joint it is attached to, the member is in tension. Tension and compression force. The answer lies in how each bridge type deals with two important forces called compression and tension. Compression is a force that acts to compress or shorten the thing it is acting on. Tension is a force that acts to expand or lengthen the thing it is acting on. What is the difference between tension and compression? A tensile force is one that pulls materials apart. A compression force is one that squeezes material together. Some materials are better able to withstand compression, some are better able to resist tension, and others are good to when both compression and tension are present. Distinguish between tension and compression. Tension force tries to elongate the material. In contrast, compression attempts to shorten the body. In tension, all forces are pulling away from the object. In compression, the forces acting on the material push towards the body. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.